And then the pump arounds, there are 3 of them. So one going from tray 14 to tray 13. Again, you use 2 trays because it doesn't really help if you put more than that in there. The return pressure is in PSIG. And then the duty is to be minus 40 BTUs per million BTUs per hour. And the return temperature is 450. So in this case, if you give it a return temperature and a duty, then it'll calculate the rate at which it will meet these specs. So you can look through here. This is in the app live. You can see what kind of pump around specs they made. Okay, and then here are the performance specs. And you'll see we have 3 side strippers and then the column. The only things you can vary in a column are feed rates, draw rates, and duties. Those are the only 3 things you can vary. So you'll see in the variables, you got the duties of 2 heater, well, the condenser's a heater even though it's negative duty. So you've got the duties here and then the stream rates. These are the product rates from the side strippers. So, and then these are the specifications for that column. They want to make stream 7 to have a flow rate of 0.03 barrels per hour. And you could, let's see, stream flow rates, stream column, liquid flow rate. Yeah, this is overflash. Usually you put a little, usually people put overflash spec of how much liquid should be coming down out of the heater section, and then they'll vary the duty of the furnace, the heater here in this case. And then see these specs, these are the important ones here. These are the D86 95% point. For this stream should be 520. What is that? Is that a kerosene or I don't remember. But these are all the side strippers. I think if I look at the side stripper names, I'll know what they are. And then the D86 95% point of this stream 11 should be 665, and then this one, I think this is like the light cycle gas oil or something, should be this one. And they use the TVP on that one because it's a heavier stream. Oh, they put these in. I didn't. Before you had to, go and delete your specs because you have to. The number of variables have to equal exactly the number of specs, or it should be. I should say it the other way. The number of specs has to equal the exact number of variables because you can't make more than. You can't over constrain the problem because just based on the degrees of freedom. Like the only things you can vary, like I said, are the stream flow rates and the duties and the feed rates. So in this case, if I want to vary the feed rate, I can add another spec in here. And these you can turn off and on easily now. Before you had to delete them completely and go back and add them in if your column didn't converge and you want to try a different spec. But this is actually pretty handy now. Okay. So let's see, did I show you everything there? Okay. And this is just to show you what I just told you in Pro 2. You can have lots of performance specifications, different types, but you can only have the number of specifications as you have the number of variables. So these are the only 3 things you can vary in the column: the duties, the side draw rates, and the feed rates. So if you can make, X number of variables, X number of specifications if that's the only number of variables you have. So that's how you would set up a column. If you were to rate a column or size a column, you need to provide more information. And Pro 2 the capability to size and to rate a column for either pack columns or tray columns, and the packing could be random or structured. And if you went to Amy's Lunch and Learn the other day, you'll recognize some of the pack column names like Raschig Rings and IMTP and all that. You can have trays and packing in the same column. Maybe the bottom section you want it packed, and the top you'll have trays, for example. And I just kind of took these off the internet. Valve tray, and it looks like this, and the sieve tray looks like this, and there's a bubble cap tray. I didn't do all the internal packing things because Amy's already shown them. To do sizing and rating, you go in here, you click on this tray hydraulics, and you can tell it to, which trays to start and which trays to end. Say, I don't know, I'll just do like this many. And here are the internals. You could say I have trays, or I have structure packing, excuse me, or random packing. And then what kind of type? Are you going to do a sizing? Sizing will give you the diameter of the column, and rating will give you the efficiency. So let's say I want to do rating. And then you need to go and enter some data. And I picked packing, right? So the only thing in here is Norton, but if you go, it says manufacturer. Then you go in here, you'll see all the different types of packing you can use. The interlock saddles, if you remember these from that Lunch and Learn. So you pick whatever you have in the column. And then the HETP, that's the height equivalent theoretical plate method, uses Frank by default. Because you have packing, right, you don't know how many theoretical plates you have. So you have to give it, you can either have it predicted using a method, or you can give it some yourself, like, 10 inches or whatever. Packing size that you have, and this is, you'll get this information from the plant. You'll know what's in your column that you need to rate. Okay, packing factor and so on. Okay. And you need to give it the column diameter. Okay, let's go back. So if you want to rate a column for trays, you need to give, I didn't show you that, but you need to give inter-tray spacing, the diameter of the tray, and what does the tray look like. For random pack columns, you need the packing size, packing factor, and then the column diameter. If you have structure packing, what type do you have? The height, the height equivalent theoretical plate, column diameter. Okay, so, and then the sizing option will calculate the column diameter for you. And it'll give you a pressure profile. Any questions? Okay, so we're gonna right now translate an existing column. So we know how to put them into Pro 2. So let's say you have a column that looks like this. And pardon my bad drawing. These are actual trays, and they usually will number them from the bottom up. Some people number them from the top down, but they usually number them from the bottom up. So you have like 11 trays here at 50% efficiency, and then from tray 12 and up, you have 80% efficiency, and you have a condenser and a reboiler. It's kettle type. So how do we translate this into Pro 2? And I gave you the answer in the next slide, so you're cheating. So you would put condensers tray 1, and then the top section has 15 actual trays at 80% efficiency, so you're actually going to end up with 12 equilibrium stages. So up here, you're going to end up with 12 for Pro 2. So 1 here for the condenser, and then 2 through 12. So 2 through 13. I can't do math anymore in my head. Will be the top section. Okay, so let's look at what happens in the bottom section. It has 11 actual trays, but it's at 50% efficiency. But that gives us 5.5 equilibrium stages, so we'll just round it down to 5. So your trays you're just modeling it so that you're assuming it's actually less than 50% efficient. Okay. And then now we decide, okay, where is the feed tray? It's going to be at 14, and let's go up and look at that again. So I've got 13 here, right? And then this will be 14th tray. So 1 to 13 and the new 14th tray. And then your last tray, how many did we say? It was 5 here, right? So the last one here would be 16, right? And then you need to add 1 for the kettle reboiler, so you have 17 total. Wait, what did I say, 19? What?
Because there was 11.
There's 5.
It'd be 19.
19, yeah, okay, yeah. All right. So then I said, what if the reboiler were a thermosiphon? Then you would add 2 stages, so your column will actually have 20. So that's how you would put it into Pro 2. Okay, any questions? That's the last of my slides, and we could go over one column input in class if you want, or if